in this episode, what is a logarithm? Coming up, back into action. Hey guys, today I will explain what is a logarithm. Sounds mysterious and spooky and makes some people speechless. Anyway, I will break it down step by step. You will not miss anything. Before I dive into this, let me get to powers or indices, which are basically related to logarithms. Say you have 3 squared equals 9. This 3 is known as a base. This little 2, written as a superscript, is known as power or index. Sometimes it's called an exponent. And this whole entire expression is called an index form or exponential form. Now, this pattern can be rearranged and turned into logarithm form or log form for short by writing log, which basically stands for logarithm, with base 3 subscripted of 9, that number on right side from your exponential form, equals 2, that power or index from your exponential version. So this 3 little base goes as a base for logarithm, and this power 2 becomes the result or answer for your logarithm. How to read this? You would simply say log to the base 3 of 9 equals 2. These two statements mean the same thing, precisely the same thing. They are equivalent. And basically, that gives you the idea, the gist, that the logarithm is just another way of expressing the power or index. In other words, the logarithm answers the question, what power a certain number, base, has to be raised to get another number. Well, it might sound a little bit ambiguous and bizarre at this point, since you are not used to it, and hopefully you are starting to get the grasp on it. Let's take a look at how to evaluate logarithms. Say you have log to the base 2 of 16, and you need to find the value, or you need to evaluate this logarithm. Well, there are a few ways of how to do this, and I will show you both. First of all, you could do these things in your head. Well, always ask yourself, what number this little 2 base has to be raised in order to get 16, that number. Again, ask yourself, what number this base 2 must be raised to get this 16? And the answer is 4, since 2 to the 4th power is 16. Because 2 times 2 times 2, 4 times, gives you that 16. And the answer is 16 for that logarithm. Well, to be perfectly frank with you, sometimes you are given a large numbers, or you are given a fractions, or roots, so things getting more pesky and more nasty. And there is a surefire way a kind of a ninja trick, a pattern that can be used and that gives you instantaneous solution for the logarithm. And I will show how to do that. How to begin, how to set off. First of all, make this logarithm equals to x or other variable. So we don't know what it is. Set it equal to x. Now, you are going to start with this little 2, with this base, and you are going to this direction counterclockwise. We're kind of wrapping around this x and end up with 16. Now, we're going to rearrange and turn this log form into equivalent exponential form. So, you take these 2 and you are going along this kind of circle. You raise this little base 2 to whatever you have on your right side, so it's x. You raise it to the x power and you set it equal to this middle number 16 that hasn't been used, hasn't been touched yet. So again, you always start with a small base. You go along this arrow, counterclockwise, anticlockwise, along this direction. You raise it to whatever you have on your right side. So it's basically going to be your variable. So what we're looking for, x. And you set it equal that middle number we didn't use. Now, you could think of this kind of a scorpion's tail. Looks like a scorpion's tail. If it makes this stick. So you go along this scorpion's tail and you end up with this middle number or your argument. So sometimes it's called the argument of your logarithm. Now, all you need to do is just figure out your x. So ask yourself, what x makes this work? What x makes this true? And since 16 is 2 times 2 times 2 times 2 equals 16. So 4 times. So it's basically 2 to the 4th power. 2 raised to the 4th power is the same thing as 16. So you could come up with the 2 to the x is just 2 to the 4th power. And since you have the same base, you could simply leave it behind. So you could drop it off. And all you need to do is just match, compare these pairs from this kind of basic exponential equation. And you could simply just set them equal to each other, and you end up with x equals 4. That means your logarithm, your entire logarithm, your whole logarithm is just 4, and you could write it down. So log to the base 2 of 16 equals that 4. And that's your final answer for that logarithm. Again, to reiterate, to recap, the idea is rewrite your logarithm into exponential form, into index form. Use this kind of mnemonic device, if you like, this mnemonic, this ninja trick of scorpion's tail. Rewrite it as a exponential form, and basically you could come up with a kind of basic exponential equation and figure out your x from that exponential equation, and that gives you the answer for the logarithm. Well, let me show some more examples of logarithm problems, and hopefully you are getting the hang of this. Alright, here a couple of log problems that I wanted to show you. Say you have log to the base root of 3 of 3. Well, again, if you could do this stuff in your head, so you could instantaneously, right off the bat, come up with the answer, that's perfectly fine, that's totally valid, go ahead. But I would like to use this kind of ninja trick, this pattern, to come up with the algebraic solution of that problems. So, first of all, set it equal to x, the variable, since we don't know what it is. X. Now, we always start with this little base, which is root of 3 in this problem. And we go along, we kind of wrapping this x and end up with this middle number 3. And all you do is just rearrange, rewrite this log into exponential, into index form. So connect it to, link it to exponential form. So it's the same thing as you take this root of 3 and you raise it to whatever you have on your right side. So you raise it to this x power, and that's equal to this middle number 3 that hasn't been used yet. Alright, so this pattern is rewritten into exponential form. And all you need to do is just figure out that x that makes this true, that makes this work. So basically ask yourself, what power, what x works for that equation? And you might spot it right off the bat that your x is just simply 2, since the taking a square root of a number and squaring at the same time, it's the inverse operations of each other, it's the reverse, they undo each other. So whatever you have inside, underneath your root, if you square it, you would end up with the same underneath, with the same number, whatever you have underneath. So, and all you need to do is just match up, compare. So you will conclude that your x is just 2, simply 2. So that basically gives you the result, the answer for your logarithm. So your entire logarithm to the base root of 3 is just 2. Here's one more log problem. So, since we don't know what does it equal, so set it equal to x, any variable, we don't know what it is. Now, link it to exponential form, rewrite it into exponential form. So it's the same thing, it's equivalent to, you always start with this little base 7, and you're going to raise it to the power of x on your right side, and equals to whatever you have inside, your argument, in other words, of your logarithm, which is 1 over 49 in this problem. And this kind of, as I mentioned before, basic exponential equations come up here, and if you need help for solving exponential equations, basic exponential equations, I have separate video and you could check out later. Now, the idea is, I will just go through this quickly. The idea is you want to always get the same base. As soon as we have the same base, we could simply drop them off. We could simply ignore them, leave them behind, and come up with the setting equal to each other powers of your exponential equation. So we want to somehow have this base 7 appears on both sides of your equations. So we have this pesky 1 over 49, this fraction. So we don't want this basically. We want to somehow make it as a power of 7. So check to see if anything in this fraction is a power of 7. And basically, yes, you could spot on that 49 basically is a 7 squared, 7 raised to the second power. So, and we could write it. So 7 raised to the x, the same thing as is 1 over 7 squared. And all you need to do is just bring this power up to the top by making this power negative. So algebra also comes up here, but we can't help it. So it's just the same thing as 7 to the negative 2. So again, when you bring your power up to the top, so you need to make it negative. So you need to switch it to negative power. And now basically we are done, we are there. Since you had the same base, namely 7, we could simply ignore that. We could simply drop it off, and we could come up with setting these powers equal to each other. So from this version you would simply conclude that your x is negative 2. Your x is negative 2. That gives you basically the answer, the solution for your entire logarithm. So your log to the base 7 of 1 over 49 is just negative 2. That's your answer for that logarithm. Well, hopefully now you are getting a grasp on it. By the way, I have a separate video which is called Logarithms. It's kind of a long video, it's about like 40 minutes I believe, but it covers different subtopics of logarithms, like properties logarithms, change of base formula, so you could check out on my playlist. Also, I have a series on logarithms, such as evaluating logarithm. It's a separate video, and I do solve log problems evaluating different logarithms, different log expressions. Also, I have videos such as expanding and condensing logarithm expressions, and you could check out later. I hope it helps you. Well, thanks for watching and training your brain. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss out my new